All right. So last but not least here in 6.4 are area conversions. So we can do area conversions here. In theory, the sort of concept and the sort of underlying ideas are the same as they are in 6.3. It's sort of a double length conversion. You're going to need to sort of do, so area, right, is a two-dimensional unit. So for us, it would be, you know, centimeters squared, meters squared, kilometers squared, etc. And so what that means for us to do different conversions is you have to do two conversions, kind of one for the length and then like one for the width is sort of a way that we could kind of conceptualize this before. What this is going to mean for us in metric, it just means that you'll double the decimal shift from whatever the like individual length conversion would have been. So let's look at an example and then kind of go from there. So say for instance, we've got, I don't know, 20 square meters. I want to convert it into square centimeters, right? So meters to centimeters, that's right, base unit. We've got deci and then centi, right? That's a conversion two to the right. And so for squared units, essentially what I need to do is I need to do that conversion twice. I need to do it kind of once for the length and then once for the width is a way to kind of think of it geometrically. So we'll double that for square meters to square centimeters. Same direction, so that's going to be from 2 to 4. We're still going to shift it to the right. So now instead of just going from like 20 to 2,000, this is going to go way up. 0, right? So this is going 1, 2, and then 3, 4. So that's like 4 extra zeros on here. So this becomes for us what? 200,000 square centimeters. Something kind of like that, right? So 20 square meters, right? What would be, you know, a 4 meter by 5 meter kind of rectangle or something, now becomes 200,000 square centimeters because, right, 4 meters is 400, 5 meters is 500, 400 times 500 would get us this, 200,000. Let's do kind of one more example, I guess, just because. What about, we can just go the other way, I guess. Let's say we have, right, I don't know, 35,000 square meters. Let's convert it into square hectometers, hectometers squared. You know, units we all use. That's going to be, right, so meters are our base unit. And then we have, right, deca and hecto. So that would be normally twice to the left times 2. So that's going to become 4 times to the left. So now this 35,000. We're going to go 1, 2, 3, 4, and we're going to get 3.5 square hectometers. Right, so all those conversions, kind of just get exaggerated to a certain extent. They obviously get bigger. And what really is happening is the shift itself gets doubled, right? You have to do it twice. Every conversion for us amounts to moving however many places. If you're going to do that conversion twice, you're obviously just kind of doubling up the shift. And that's the idea. Again, you can do all this stuff, writing it out and sort of writing out the multiplication or division by 10 or by 1,000 or however you want. You can sort of write everything that way. But I think these unit shifts, just sort of, you know, getting it just visually directly from the table, I think is pretty fast and pretty easy to remember. So as long as you have this table and you have these prefixes kind of in order with the base unit, you know, you should be good to go. So that's the metric system. 6.5 is coming up next. That's going to be trying to sort of fit the metric system and the American system together. I'll spoil it a little bit. They don't really fit together all that well, but we'll try to make it work as best we can. Essentially, just the numbers get really, really awkward because the systems weren't really designed to fit together. So there's lots of decimals coming up, but, you know, we'll live. See you then.